Hello everyone and hello doctor. We are from Group 11 and today we will present our operation management assignment titled Protect Our Planet to Reach Net Zero Carbon by 2015, Leading the Future of Sustainable Manufacturing. Our collaborating industry partner is Turrima Agro Biotech. Turrima Agro Biotech focus on sustainable biofertilizer. The company is also ISO certified company. In addition, Turrima provides certified organic inputs. This slide shows the company profile of Turrima Agro Biotech. The company is led by Dr. Mulyono, the CEO of Turrima Group. Turrima Agro Biotech is an Indonesian agro-biotechnology company established in 1998 and headquartered in Sragen, Central Java. The company focuses on the development, production, and distribution of high-quality organic fertilizer, supported by the scientific research and modern technology. Turrima Agro Biotech has also support sustainable agriculture and food security and serve international markets such as Australia, Cameroon, France, Kuwait, and Malaysia. Our case study interview question with Mr. Naufal as the R&D from Turrima Agro Biotech, we are focusing on four key points like first man, mission, material, and method. So in the next slide, we will explain more detail.
Moving on to our first element of our 4M analysis, man. We asked how Turrima Agro Biotech ensure teamwork and accountability in their carbon reduction effort. We found that carbon reduction is a cross-functional effort involving production, quality control, sustainability, and R&D departments. They use a unique operational strategy where the production team maximizes output to provide the R&D team with more materials for refining low-carbon products. This high-volume approach allowed them to process 25 tons of organic waste into 15 tons of beneficial product every week, significantly reducing their environmental footprint. To maintain high standards, they enforce a strict 30, 60, and 80-day rule. New products are developed in the first 30 days, lab tested within the 60 days, and finalized with the mandatory quality control check within 80 days. This, combined with their internal product operation certificate (POS), ensure total workforce accountability. Our second question focused on how Turrima Agro Biotech keeps its workforce trained on the latest sustainable farming techniques through external network. We found that Turrima heavily utilizes collaboration with academia. They facilitate information transfer by hosting annual exhibition and technical discussion for students and lecturers. They also provide on-site learning through field trips, allowing students to study bioinsecticide effectiveness firsthand. To support future experts, they provide specialized products like AHA Biometarhizium or AHA Biotrichoderma for student universities to help them with their final year research studies. And beyond academia, they partner with other firms for open field studies to develop new organic protocols for crops like corn, rice, cacao. Crucially, all their training is strictly aligned with the Indonesian government regulation, which is to reduce chemical soil use and promote renewable energy, ensuring their workforce remain at the forefront of the green transition.
Next, I will explain the type of machinery used by Turrima Agro Biotech to support low carbon and efficient production. First, Turrima use low carbon machinery powered by renewable energy instead of fossil fuel. They also replace the conventional fuel machine with electrical based equipment, which help reduce carbon emission and energy waste. In addition, Turrima apply waste to resource technology, where organic waste is processed to maggots. These maggots are used as animal feed or converted into biomass energy, reducing landfill waste, methane emission, and improving overall efficiency. Moving on to the improvement and strategy for achieving a carbon-free industry, Turrima focus on technology improvement that reduce carbon emission across production system by applying circular economy practice. They use solar energy to power operation and biomass energy to convert organic waste into renewable energy. Another key innovation is maggot-based farming, where maggot produced from organic waste are used as animal feed. This approach reduces waste, lower emission, and support a more sustainable and environmentally friendly industry.
Okay, as for these questions, actually the agronomist follows a four circular stage protocol which aim to balance the environmental health with the maximum yield. So the stage one is actually the baseline diagnostic where they perform a high resolution analysis of the field's chemical parameters and also the carbon levels in the soil. So this is to ensure that they are not just looking at the surface only. And stage 2, they develop a prescription and formulation which specifically to introduce the targeted inputs that will fix the deficiencies identified in the soils. And stage 3, they will move to the analytical trial phase, where they conduct a control field trials to see how the crops interact with these new inputs that they introduce in the real world settings. And last stage is if the results meets the KPI, so they scale the operation to the full maximum. So if not, the protocol will circle back to the diagnostic phase to recalibrate and refine the formulation until it's perfect. Moving to the technical side of the product itself. So the question 6 covers the Turrima's primary formulation method. So they specialize in a multi-strain microbial inoculum technique, so which creates a synergistic blend of azotobacter and also the beneficial fungi like Trichoderma. So the process utilize either a stabilized liquid or carrier-based inoculations. So the key technical control here is to keep these microbes in a dormant yet a viable state. So meaning that they are asleep in the bottle or wake up and act immediately until application. So the ultimate goal of this formulation is the biological soil reordering. So this is a powerful process where the microbes actively sequester the carbon and also restore the soil's mineral architecture and essentially rebuilding the soil from inside and out.
For question 7, we looked at how Turrima minimizes waste and promotes reuse in its production process. Turrima adopts a circular economy approach, which means waste is not simply disposed of, but instead reused or converted into valuable resources. One key action is source separation, where organic residues are separated early in the production process. This enables the economical recovery of materials that can still be reused. So in addition, Turrima practices composting and reuse of fermentation byproducts. These byproducts are not treated as waste, but are repurposed to reduce overall solid waste generation. Residual materials from biofertilizer and liquid fertilizer production are recycled and reused as secondary raw materials and soil amendments. So these practices help to significantly minimize material waste, reduce environmental harm, and improve overall resource efficiency. Moving on to question 8, we examine whether Turrima's carbon reduction efforts comply with regulations or if regulatory failure is the issue. Our findings show that Turrima's raw materials and production processes fully comply with environmental regulations, including carbon emission and ecological laws. The carbon reduction practices used are legal, safe, and regulation compliant. More importantly, sustainability is deeply embedded in Turrima's core value. This includes reusing resources, reducing waste, and regenerating natural systems. Sustainability is not treated as a checklist requirement, but as a fundamental operational principle. The results suggest that the main challenge in carbon reduction is not the lack of regulations, but rather the effectiveness of policy implementation and industry commitment. So Turrima serves as a model organization by going beyond compliance and actively addressing broader environmental issues such as deforestation, soil degradation, and loss of soil health.
The Indonesian agrobiotech industry is no longer viewing sustainability as a mere add-on but as a fundamental pillar of operational management. Through the rigorous application of the 4M, companies like Turrima Agrobiotech are proving that industrial growth and environmental preservation can coexist by transforming agriculture from a primary carbon source into a vital carbon sink through advanced biofertilizer and waste-to-energy systems. The sector is making the ambitious goal of net zero emission by 2050 a tangible reality. To maximize the impact of sustainable agriculture and realize the United Nations SDGs, the following actions are recommended. First is open for external investment. Next, scale operations to new markets. Next, enhance community collaboration. And finally, drive technology integration. That is all from us, and thank you so much for listening to our presentation.